Assalamualaikum dan selamat pagi. Kita masuk tajuk limit at infinity. If x is moved increasingly far away from the origin in the positive direction, that means x approaches a positive infinity and fx get closer and closer to the L, that means fx approaches L, then we write limit x approaches positive infinity fx equal to L. Okay, here when x approaches positive infinity, when x approaches infinity and the value y approaches this value y approaches L. Okay. Number two, if x move increasingly far away from the origin in the negative direction, x approaches negative infinity and fx get closer and closer to L, fx approaches L, then we write limit x approaches negative infinity fx equal to L. So when x approaches negative infinity, the value y approaches L. Example 1. Sketch the graph fx equal to 1 over x squared. Hence, find the limit x approaches positive infinity fx and limit x approaches negative infinity fx. So this is the graph for fx equal to 1 over x squared. Look at here, when x approaches negative infinity, so the value for y approaches 0. This is a value for y approaches 0 here. When x approaches positive infinity, so the value y, this is a value y approaches 0. Limit at infinity, when n greater than 0, then first, limit x approaches positive infinity 1 over x power of n equal to 0, and limit x approaches negative infinity 1 over x power of n also 0. So we get two properties when x approaches positive infinity and when x approaches negative infinity. For 1 over x power n, we get the both answer equal to 0. Okay, look at this example. Limit x approaches positive infinity 4 over x. So the answer equal to 4 times 1 over x. Limit x approaches infinity. So the answer equal to 4 times 0, because this is 0, equal to 4 times 0 equal to 0. Number 2, limit x approaches positive infinity 5 over x cubed. We can write as a 5 times limit x approaches positive infinity 1 over x cubed. So this part equal to 0. So 5 times 0 equal to 0. Number 3, if x approaches negative infinity for negative 1 over x squared, we write negative 1 limit x approaches negative infinity 1 over x squared. This is also 0, so negative 1 times 0 equal to 0. Example 2, find the limit at the infinity for the following. First, limit x approaches infinity 2x plus 3. So when you substitute infinity, you get what? 2 times infinity equal to infinity plus 3. So infinity plus 3 equal to infinity. B, limit x approaches positive infinity x squared plus 3x. When you substitute, you get infinity squared plus 3 times infinity. Infinity squared, you get infinity plus 3 times infinity, infinity. Infinity plus infinity equal to infinity. C. Limit x approaches negative infinity 2 over x plus 5. So we can write as a 2 times limit x approaches negative infinity 1 over x plus 5. When you substitute infinity, negative infinity, that means you get a 1 over infinity. So the answer equal to 0. This part becomes 0. So 2 times 0 equal to 0. Okay, D. Limit x approaches negative infinity 1 minus 3 over x cubed. So this part 3 over x cubed becomes 0. So 1 minus 0. So the answer equal to 0. Okay, limit at infinity for rational function. If limit fx over gx when x approaches infinity, when you substitute, you get infinity over infinity. So we divide each term by x to the highest power of the denominator. Okay, look at this example. Find the limit of the following. First, limit x approaches infinity for 2x cubed plus x squared minus 3 over x cubed plus x plus 3. So when you substitute infinity, you get infinity. And this is also infinity. That means infinity over infinity. So we divide the highest power of x in denominator. No, denominator. That means x cubed. So divide is term by the x to the highest power of denominator. So the denominator here is x cubed, so we divide dengan x cubed. Okay, after that you simplify. Okay, this part 1 over x, 3 over x cubed, 1 over x squared, 2 over x cubed. This becomes 0, this becomes 0, this also 0, and this is also 0. This is 0, this is 0, this is 0, and this is 0. So you get the answer 2 plus 0 minus 0, 1 plus 0 plus 0. So the answer equal 2. Okay, number 2, x approaches negative infinity for x squared plus 2x minus 3 over x plus 1. The highest power of x equal to x. So you divide all term by x. And then you simplify. So this part 3 over x, 1 over x becomes 0. When this becomes 0, you get what? X plus 2 over 1. That means limit x approaches negative infinity, x plus 2. X plus 2, you substitute in negative infinity, you get negative infinity plus 2, negative infinity. Thus, the limit does not exist. Okay, number 3, limit x approaches infinity for x squared plus x plus 2 over x cubed plus 1. So the highest power of denominator is x cubed, so you divide by x cubed, all term by x cubed, and then you simplify. This is you simplify, but 1 over x becomes 0, 2 over x squared becomes 0, 2 over x cubed also becomes 0, 1 over x cubed becomes 0. So you get what? 0 over 1. This is 0, this is 1 over 1. So the answer equal to 0. Okay, number 4. When x approaches negative infinity for square root x squared minus 4 over 3x plus 1. So you divide by x because the highest power of denominator equal to x. So we divide by x. Square root x squared minus 4 divided by x. 3x over x, 1 over x. Okay. Why we write negative here? Because x, when x approaches negative infinity, that means x is negative. Bila x pergi ke negative infinity, maka nilai x tu ialah negatif. Jadi, mengapa kita tulis square root x square? Sebab square root x square kita nak letakkan di dalam square root. Jadi, x sama dengan square root x square. Tapi nilai dia adalah negatif. Ni x less than 0 negatif. Maka square root x square equal to negative x. So, x sama dengan negatif square root x square. So, we write x ni sebenarnya sama dengan negatif square root x square. So, we write negative. Kita masukkan dalam square root. Jadi, x tadi jadi x square minus 4 over x square. Over 3 plus 1 over x. This equal to 1. This becomes 0. 1 over x also 0. So, you get the answer equal to negative 1 over 3. Okay, number 4. Divide each term by the x to the highest power of denominator. Limit x approaches infinity, x square minus 1 over x plus 1. So divide by x. Okay, this one here. Divide by x. So over x, x over x plus 1 over x. Square root x square minus 1 over square root x. So you get answer limit x approaches infinity. After you simplify, you get 1 minus 0 over 1 plus 0. So the answer equal to 1.